Welcome you all. Today I'm gonna talk about my project. The project title is Feasibility Study for Replacing Oil-Fired Heater with Thermic Oil-Based Heating. CT is the largest supplier of instant tea powder within the global Unilever group of companies. The sole supplier of black instant tea powder for the Pepsi-Lipton joint venture, which produces world-renowned brands like Lipton, Ready to Drink, and Brisk. While their production processes are highly efficient, we have identified a major challenges in heating system. Their reliance on diesel-fired heaters. The problem with diesel-fired heaters include high operational costs due to increasing price of diesel, insufficiencies in energy use leading to unnecessary waste, environmental concerns as burning diesel contributes to carbon emissions. To address these issues, our team conducted a detailed feasibility study to assess the potential of thermic oil-based heating systems. This alternative aims to enhance energy efficiency, lower cost and minimize environmental impact. Our first step was to analyze the existing system. We found that the plant consumes 1,830 liters of diesel per day, which is significant expense. The current air heating system experienced 6 Celsius temperature loss due to poor insulation in ducting. Given these challenges, we explored whether thermic oil-based heating systems could provide a cost-effective and sustainable alternative. After conducting through research, we determined the required heating capacity. The heating demand for air heating and fuel dyeing is up to 2 million calories per hour. The system can operate efficiently with the fuel mix of 50% tea waste and 50% of wood chips, making use of byproducts from the plant. In our study, we evaluated 3 different configurations for implementing the new heating system. The option 1 is no heat recovery. All heat for fuel dyeing and hot air generation is directly supplied by the thermic oil heater. Simple setup with lower installation complexity is an advantage, and the disadvantages are higher operation costs due to increased fuel consumption as well as the greater environmental impact. Second option is partial heat recovery. Heat is recovered from thermic fluid exhaust gases to generate hot water for fuel drying. Reduced fuel consumption and lower operational cost as well as the improved overall system efficiency are the advantages, and the disadvantages are requires a moderate initial investment and slightly more complex installation and maintenance. The last option is maximum heat recovery. Implement full heat recovery from thermic fluid exhaust gases, maximizing energy savings. Lowest long-term operational costs due to maximum fuel savings, and most efficient system with a significantly reduced environmental impact are the advantages, and the disadvantages are highest in initial investment due to advanced heat recovery and system enhancement, and greater complexity is in installing and operation. When we talk about the knowledge gaps relevant to the problem, during our study we identified several critical gaps that need to be addressed to ensure a smooth transition. The first one is diesel consumption data. Our study confirmed that diesel consumption is 1,830 liters per day, but additional analysis is needed on specific cost-saving opportunities. The second one is heat loss reduction. The 6 Celsius temperature loss in the current system requires better insulation to improve the efficiency. And the third one is environmental impact. While we anticipate lower CO2 emissions, we need quantifiable data on carbon saving. And the last one is air pressure requirements. More information is required on air pressure needs for both the heater inlet and spray dryer inlet. Addressing these gaps will help us fine-tune the new system for maximum efficiency and savings. When we talk about the presented solid and realistic project plan, gather baseline data on an existing system. As an example, calculate airflow rates, fuel consumption, and heat requirements. Log operational parameters such as current temperature profile and fuel efficiencies, and determine the theoretical and practical heat requirements of air heaters and fuel in drying process, as well as choose a suitable heater capacity based on heat loads and expected losses. Under the adapted innovative methods, I am mainly focusing on 3 points. So the first one is advanced heat recovery systems. Design options for recovering heat from the thermic fluid exhaust, significantly improving system efficiency. And the second one is fuel optimization. Proposed a sustainable fuel mix of tea waste and wood chips, utilizing plant byproducts to lower operational costs. And the other one is custom thermic oil heater design. Tailored the heater to the plant's specific requirements to ensure compatibility and efficiency. And the last one is energy conservation focus. Introduce the use of advanced thermic fluid for better heat transfer and reduce losses. So we are coming to the end of this video. For the final one, we are going to talk about delivered within allocated time with a good narration. So I am going to explain this topic under 3 main subtopics. The first one is timely execution, the second one is clear and effective communication, and the last one is value of good narration. Under the timely execution, the feasibility study was conducted within the planned timeline, ensuring that data collection, analysis, and report preparation were completed without delays. A clear and well-structured report with detailed findings and recommendations was provided promptly to ensure further discussion making. And also, all tasks such as heat load calculations, techno-commercial comparisons, and investment evaluations were completed as planned, meeting stakeholders' expectations. And the second one is clear and effective communication. Effective communication with the plant team ensures alignment on objectives and data requirements before the study began. The final presentation invited discussion and feedback, ensures stakeholders fully understood and recommendations and next steps. The final one is value of good narration. The report and presentation clearly conveyed complex technical data like heat loss calculations, investment comparisons, in a simple and understandable manner. This is all about my project. Thank you.